Welcome back to ASVAB Roadmap. Today, we're going to talk about divisibility, prime numbers, and prime factorization. So as always, let's get right into it. After learning about division, it's only natural to learn about the concept of divisibility. Numbers are only divisible by certain other numbers, which means that they can only be divided evenly in certain ways. Take the number 10. 10 can be divided by number 1, which just gives 10. In this way, every number is divisible by 1. 10 is also divisible by 2 because it is an even number. Even numbers are the ones that are divisible by 2, like 2, 4, 6, 8, 10, and so on. However, 10 is not divisible by 3. If we tried, we'd get 3 remainder 1. 3 does not go into 10 evenly. So while 1 and 2 are factors of 10, 3 is not. 4 also is not. 5 is a factor of 10 because 5 is half of 10. 10 divided by 5 is 2, so 5 is a factor of 10. But from there, no number bigger than half of the larger number will be a factor except the larger number itself. So 6, 7, 8, and 9 are out. And lastly, we say that 10 is a factor of 10 because 10 divided by 10 is 1. So 1, 2, 5, and 10 are the factors of 10. This brings us to an obvious question. Are there numbers that have no factors? Technically no, because all numbers have 1 in itself as factors. But what about beyond that? Are there numbers that have no factors besides 1 in itself? There are indeed many, and numbers that fulfill this criterion are called prime numbers. What are the prime numbers? Let's start with 1. 1 doesn't count because 1 in itself would be the same thing. 2 counts, as does 3, because these are so small that there can be no other factors. But once we get to 4, 4 is divisible by 2, so 4 is not a prime number. In fact, no even numbers except for 2 can be a prime number because they are all divisible by 2. Only odd numbers can be prime numbers. 5 is a prime number, as is 7, but 9 is not because it is divisible by 3. One would think that this can't go very far, because once numbers get big enough, there have to be factors in there, right? But there are some astoundingly huge prime numbers. The largest one discovered so far has millions of digits, and it took thousands of computers running simultaneously for days to find this number. In fact, there are infinitely many prime numbers. So now that we understand what prime numbers are, we can understand why we must factor numbers until only prime numbers remain. Take 20 for example. We can represent that as 5 times 4, and 4 can be represented as 2 times 2. So factoring 20 gives us 5 times 2 times 2, which are all prime numbers. Notice how we are never done until we are left with only prime numbers. Alright guys, that was divisibility, prime numbers, and prime factorization. We have some more videos coming up about these topics, so stay tuned.